Okay, I was asked to look for the noise margin, which is VOH minus VIH, and then the noise margin for my low, VIL minus VOL. VOH is the least voltage considered high at output, while VIH is the least voltage considered high at the input, while VIL is the maximum voltage considered low at the input. Then VOL is a maximum voltage considered high at the output. So I was able to handle that using my data sheet. I make use of my data sheet for every data I need for VOH, VIL, and so on. Then I was asked to look for the switching point. My switching point is obviously my switching point is half for VOH, which is 3.94 divided by 2, which is 1.97. But we can make use of formula, assuming that our VTN is 1, our KP is 1, and our KN is 1. Then I was able to get switching point. Then I was asked to look for the sizing ratio here. Then I was able to make use of the formula. Then I assumed that the mu N is equal to 3 times mu P, which is electron mobility is 3 times the electron mobility is 3 times the mobility of O concentration here. So I assume it is 3. Then I was able to get the sizing ratio at 3. Okay, for number 3, I was asked to sketch the input and output pulse passing through the inverter, showing the propagation delay approximately. So since I was given 5.5 volts, so I had no choice than to consider the 10th condition between 5.0 plus or minus is 0.5 volts. Then from my data sheet, I got my propagation delay from low to high at 6.9 nanoseconds. Then my propagation from high to low, that is 7.9 nanoseconds. Then I look for my fourth time, and then my fourth time was given in the data sheet 3.9 nanoseconds. Then my rise time TR was also given 10.0 nanoseconds. Then the time taken for it to from low to high, I was able to make use of my formula 2.2 over 0.7 times propagation delay from low to high, and so on. Then I was able to get 21.7 nanoseconds, 24.8 nanoseconds. Then I was able to plug them here. This is propagation delay from low to high, 6.9 nanoseconds from high to low. This is it here. Then my rise time, then my first time is here. Then I was able to plot everything here. Then the first question, giving a load capacitance of 15 picofarad from the maximum propagation delay, assuming a 1 micrometer process, determine the input and output capacitance. Okay, so from my capacitor load is 50 picofarad, then my Cox is 1.75 femtofarad. Then I make use of my formula CL plus Cox. Then I was able to get C out here. So then from this C in, I make use of my formula 3 over 2 C out. Then I was able to get 7.5 times 10 to the minus 11 farad. The last question, I was asked what I'm going to do, that how am I going to sketch it if I want to increase the noise margin of the load. Then I said then I will have to increase the width of the PMOS. Then the width of the PMOS must be greater than the width of the NMOS, which I sketch here. Thank you.